All right, okay, so welcome to another office hours for Jenkins X. We've got a couple of things we're going to try and start walking through. We figured that we've got a lot of focus around Jenkins X3, what we're doing there, so we want to try and make sure that we're covering some of those early thoughts and design efforts that we're doing around that, and so that we're preparing ourselves so that we can get people to start actively contributing and helping getting involved as well. I don't know if anybody's seen, but there is I suppose I can share my screen so that people watching the recording. There is a GitHub issue on the enhancements repo, the Jenkins X enhancements, where we're just been capturing some of the high-level links to other areas and Google Docs and design docs that we've been putting together. It also talks about some of the principles that we're looking at, some of the areas that we, from the learnings from Jenkins X we've had so far, and some of the mistakes we've probably made, and some of the areas we want to kind of improve. I think we can probably dive in shortly into some of the things, a little bit more tangible efforts that we've been working on. But this, I guess these principles are really focusing on less magic, I think, is one of the things. Lots more things being a lot more declarative and clear, transparent what is actually happening, both in actually when we're actually installing and we're working with Jenkins X, but also around the UX of Jenkins X as well. We know that there's been lots of challenges around the installation of Jenkins X, running on your local laptop, for example, and David, I guess, David, you can agree to that?
I certainly can. I'll give it a shot for now.
That's great. And we've had huge amounts of feedback, and we know it's been a common problem. We could have looked at keeping on fixing issues within boot. What we wanted to do was take the opportunity to look at architecturally how we were doing things, looking at some of the principles other projects use, like Kubernetes, how they make things a lot more declarative with the YAML they produce, and they want to match state with with what people desire, and taking on some other areas as well. So some of this work, I guess, started a little at the start of the year, where we wanted to separate out some of the things that Jenkins X was doing. Traditionally, Jenkins X has been able to create clusters and manage cloud resources, which was kind of good at the start, but then we've quickly realized that Jenkins X doesn't really want to be doing that. There are other open source projects and other approaches that customers' environments are expecting, and other projects like Terraform, and there's, what's the other one? James, I can't remember. Console? No, what was it?
Crossplane.
Crossplane, exactly, yeah. Where you'd be able to manage cloud resources from outside the Jenkins X installation. We wanted to reduce how much Jenkins X was actually doing, and so allow other people to just bring a cluster along, and then Jenkins X has a clear separation. You can actually install on that. So making those boundaries a lot clearer as well. So I guess with that, if people go and have a look at this, we're updating it all the time as we're working through these things. There's an overview of some of the UX that we're looking to do. Originally, Jenkins X went through a lot of wizards to be able to find out what people wanted, what type of cluster people wanted, what they wanted installed in there. But then that also complicated the installation, because Jenkins X was doing a lot about asking questions and lots of different permutations, which we ultimately then needed to have automated testing around. So there is kind of this UX that we've been looking at around, what does the user want? The user knows pretty much up front what they actually want to be doing as far as what kind of cloud provider they're using. It might be GKE, it might be EKS, it might be a homegrown Kubernetes. They might have other things like what secret store they have, Vault, or maybe just they don't have a secret store. Maybe they're using Google Secrets Manager, or any native cloud provider Secrets Manager. So some of these things up front we kind of knew, people can decide beforehand. So this is where we kind of trying to simplify things, people making decisions beforehand, before Jenkins X actually then goes into things. James, did you want to add in anything there? I'm just kind of talking, so you just jump in at any point.
You're doing well so far.
Okay. All right, yeah, so have a little look at this. One of the other, let's dive into how actual tangible examples of what this is. So here we go. You kind of, as a user, you might decide that you want GKE and Vault for an example. Now,
actually, James, do you want me to just take over here, because I was going to show I was going to show the new docs. I've not quite done a pull request yet.
Go for it.
I'm going to show the new docs that kind of walk through what you're just about to show from GitHub.
Okay. Do that. I'll be better.
Share my screen. I'll turn my video off just because my internet's not brilliant. I was hoping to get this pull request merged, well, at least previewed before the meeting, but unfortunately I've got loads of bad links. It's taken me a while to fix all the bad links, so we don't have a preview until all the links work, which is good, but when you're rushing for an office hours, it's not awesome. Okay, can you see my laptop screen?
Yeah.
Maybe just one window on it with the docs. Yeah?
Yeah.
Cool. So this is the first, it's not quite pull request yet. Well, there is a pull request, but it doesn't actually build a preview yet of the 3.x docs. It's similar to the 2.x docs, as in it just goes, the getting started tells you how to set everything up. And just the bit that James was starting to explain is we have a slightly different way of getting started. Traditionally with 2.x, we have this JX binary that does all this kind of magic stuff of making Git repositories. You do some Terraform stuff, you create a requirements file, you run some magic commands on your laptop, and then you do some other stuff. We've changed it slightly to use a kind of a quick start model so that we have Git repositories for different common setups. So we've only currently got documented gcloud with Terraform and gcloud with gcloud command line. We hope to have Amazon and Azure fairly soon. And the basic idea is each one of these has a link to create a new Git repository. I'll just move this into a new window. So if I just click on this Git repository link, it opens a new window on github.com to create a new Git repository. And it's using the GKE Terraform Vault as the template to make this new repository. So if I just make a new Git repository called JX3 Demo Vault 3, click create, this is going to create a brand new Git repository on github.com with all the source code to be able to boot up Jenkins X3. So rather than using magic wizards and CLIs and all this other kind of stuff, we're just using github.com. Now what we're hoping is, this is the actual upstream source code. So we've got this organization that James was just showing, where we've got a bunch of starter quick starts. We're hoping we can expand this. Once they're all basically working well, I'm hoping we can expand this so we can have a bunch of Amazon ones, a bunch of Azure ones, a bunch of standalone Jenkins, a bunch of Jenkins ones, a bunch of Tekton ones, a bunch of standalone Kubernetes ones and whatnot. Because there's quite a lot of, the difference between, for example, Docker versus Kind versus Minikube versus Terraform on an on-premise cluster versus GKE versus Amazon versus Azure, they're all quite different. And they involve changes to Terraform or not using Terraform, or, for example, there's no point using Terraform if you're using Docker for Mac or Docker for Windows. If you're using Minikube, there's no real need for Terraform because you're just using a little temporary cluster on your laptop. If you're on-premise, you probably want to use Terraform, but somebody might have already created the cluster and the cloud resources for you, so you might not want the Terraform part. So there's going to be lots of different permutations of where you start from. We're hoping in the docs we can have all the common ones for you, so you just kind of click on the closest match to what you need, whether it's on-premise, public cloud, Terraform or not. Eventually, as James said, it would be awesome to have somebody create a crossplane.io version, or maybe a Kubernetes API, Kubernetes cluster API version, possibly Google Cloud Connect, which is using CRDs to define cloud resources. Basically, however the cloud infrastructure gets created is an implementation detail. Pick the tool that you want to use. We recommend Terraform as the default if you want some kind of vaguely production setup, because Terraform can create missing resources or upgrade them over time. Let me show you the Git repository that I just created. and I've just been recently booting. So this is the Git repository that gets created. I was just going to walk through a little bit of what's in the Git repository for the Terraform Jenkins X3, just to kind of show you what's behind the curtain. Now, if you've used Jenkins X before, you probably know Jenkins Jx Requirements pretty well, and this looks pretty much the same as it always has. So there's a Jx Requirements. There's also a Terraform script or file, which if you've used Terraform before with either Google or Amazon or Azure, you'll know this piece well. That's defaulted for you into the quick start, so you don't have to tinker with that file or create that file by hand. There's one for Google and there will be one for Amazon Azure fairly soon. Although depending on the cluster you create, there will be some steps to tweak that. So for example, if I look at the README in here, oh, that's slightly out there. If I look at the README that's linked from this, this page, there's a documentation site that describes how to set up your infrastructure. And you basically clone the repository you've just created. And then for GKE, you set this environment variable, you run this configure script, and then you run apply, which then does all the Terraform magic. So it's very, very simple. You don't have to know anything about Terraform. You could just create a quick start Git repository and basically boot it up. It might be using Terraform under the covers. It could be one day using Ansible or any other tool. We're trying to keep the same kind of look and feel in each of these Git repositories. So there's basically a configure script, which configures things like the Google project, the Amazon project, or whatever. And then an apply script, which does the Terraform init and apply stuff. And then you should git commit any files that have changed, because it tends to modify some files to customize in Git what project you're using on your cloud provider. The final step is going to disappear soon, but this is currently in place until it disappears. We have this thing called a Git Operator, which is a really simple project. Incidentally, this is the, this one, Jenkins X-JX CLI. This is the top level project for all the 3.x command line interfaces. And one of the traditional issues with Jenkins X2 is we have this massive JX binary that has everything inside it. So we have this huge monolithic binary with a gazillion things inside. With Jenkins X3, we split this into a whole bunch of different plugins for different things. Now, different developers might not need these plugins. So the plugins can download themselves on the fly if you need them. If somebody else sets up your Jenkins X installation, you don't need the admin or the GitOps plugins, for example. You'll just tend to use pipeline and previews mostly. Possibly, oh, definitely project probably for setting up new projects. So depending on exactly how much of the dev or ops spectrum you work with Jenkins X, you may need some or all of these plugins. The plugins load on the fly. Each one of these plugins is a separate Git repository and microservice. There's a bunch of other components. So the Git Operator is the thing I just mentioned. Octant is a thing we showed last office hours. And there's a bunch of other libraries as well that we've gradually refactored out into separate Git repositories. Actually, Lighthouse config is now over. We now use Lighthouse directly. I should update this page. So the Git Operator is a very, very simple microservice and a very simple command line, which essentially just runs a small deployment in a Kubernetes cluster. And all it really does, it works a little bit like Flux. It just pulls a Git repository for changes. And when it sees a change, it triggers a Kubernetes job. Now, where it slightly differs from Flux, and rather than just doing kubectl apply, that job could do different things. So that job can modify Git or other steps. So the job can do different kinds of things. So all it really does is just query the Git repository you tell it to use, queries that, pulls that Git repository for changes, and whenever there's a change, it runs a job. Now, where's that job defined? The job's defined in Git. So let me go back to this Git repository. So this is the Git repository that was created from this quick start. If we look in the .jx directory and we look in the Git Operator folder, this is the job that's defined in the Git repository that defines basically what job runs whenever Git changes. And this is a very, very simple kind of pseudo pipeline that just clones the Git repository and then runs a very simple make apply command. So it's super, super simple. Make apply just uses this Git, this container image, and runs make apply on the make file that's in Git. So the actual steps that take place in installing Jenkins X or upgrading Jenkins X is all defined by a very simple makefile, which is actually defined in this file here for implementation detail reasons. So if we're looking there, here's the makefile. There we go, that's the makefile. Now, the reason we've gone with the makefile, traditionally we used to use Jenkins X pipelines and Tecton and turning those into command line tools and whatnot. We went with the makefile just because it's really easy for people just to edit and test locally. And mostly the makefile is just a whole bunch of commands that do stuff. So for example, there's a command here that runs Helm file. So given a Helm file, it will just generate the template YAML for all of the Helm files defined in Git. There's a whole bunch of other steps, which I'll talk about later, but they're completely implementation detail. If you don't really care how Jenkins X works, you don't have to look at this file at all. If you really care about how Jenkins X works or want to tweak it or customize it, have a little look at this file and tweak it, right? So there are a whole bunch of different JX GitOps commands that do things like add a label to all the YAML before we install it, modify the ingress, add an annotation, generate a hash on some resources based on the configuration to force a rolling upgrade. So the whole bunch of these steps, which you can opt out of if you wish. You can opt in or out of Helm, Helm file, kept, customized. You can use any permutation of tools. Jenkins X is now completely loosely coupled from Helm 2, Helm 3, Helm file, kept, and customize. All of the binaries for Helm 3, customize, Helm file, and kept are all in the container image by default. So you could use any of those tools out of the box without worrying about having separate container images or any kind of complexity like that. So how does the Helm file stuff work? So by default, we use Helm file for everything, but you can opt out and do things with kept, with customize, with whatever you like. You could use Helm file to get the first set of the resources in place. Then you can go ahead and use customize to modify them if you like. Now, why are we doing all this kind of stuff? So one of the most common things we hear from folks is, I have a cluster, it's slightly different to the out of the box, and I want to add an annotation somewhere, or I want to modify a namespace. I want to move something from namespace A to namespace B. I want to delete a resource, or change a resource, or add a resource, or modify a resource. Pretty much all people ask for from an installation perspective is not usually relating to, for example, buckets or Google Cloud stuff or Amazon stuff. It's normally, how do I tinker with Kubernetes resources? So we want to make it crazy simple for people just to use any tool they know about. That could be Helm file, it could be Helm, it could be customized, it could be kept. It could be just a shell script. You could just do some sed or some Perl or whatever it is you want to do. Whatever tool you know, we want you to be able to use that tool to modify the YAML before it gets applied. So by default, we use a Helm file, and here's a default out-of-the-box Helm file. The Helm file has a bunch of default YAML files, which are passed into Helm as values files. And then these are all the charts that are included by default. So there's a bunch of resources. There's something called external secrets. There's a bunch of CRDs, there's Nginx, there's Tecton, Lighthouse, and out of the box, Nexus Chart Museum and Vault using an operator. There's also this thing called Pusher Wave, which is a microservice you can opt out of if you wish, but it's a really nice microservice that watches all of the secrets which are used by deployments. And if any of those secrets change, it triggers a rolling upgrade on those deployments. That's really, really awesome because it means you can modify your secrets at any point in time using either Vault or something like external secrets. And you can modify your secrets, whether they're in Vault, whether they're in Google Secret Manager, Amazon Secret Manager, it doesn't really matter where they come from. Whenever the secrets modify, your deployments automatically do a rolling upgrade, so you get the latest secrets all the time. So these are the default Helm file. One of the first things Jenkins X does as it's booting is it takes these canonical charts and enriches them with data from the version stream. So it enriches them with things like what's the version number of the chart, what's the what are the additional values files we use to configure the chart in the version stream. And let me just find an example that fully booted, because the example I've got right now, I haven't quite booted it yet because of a bug, which unfortunately I couldn't fix before this demo. Let me just find. Go for
Whilst
it.
you do that, I can add a bit of colour to people that are familiar with the version stream. It's the way to be able to gate, have a quality gate to be before we release full release of Jenkins X, so people can then consume it using an upgrade. In there's a number of things like configuration and default values, but it can be. It's another one of these things we kind of alluded to at the start. It's kind of magic that happens, you know, when you are applying and installing a Helm chart or an application. There's lots of values coming from left, right, and centre. So that was really just to give a bit of colour, and then James.
Cool. Thank you. Phew, that gave me time to find this example. So here's an example from a BDD test that ran, and this one isn't using Terraform. This one's using just vanilla G-Cloud commands. So you could create a quick start that just uses the Amazon command line to create a cluster. It could use EKS CTL. It could use, I mean, any tool you like to spin up the cluster instead of the resources. We do recommend Terraform because it gives us a nice canonical way of doing this and managing on the cloud resources. But lots of people have got lots of different environments. So we want to allow people to use any tool they wish and create their own quick starts. But this quick start, if you look in the bin directory, the apply and the create cluster uses G-Cloud here. So we're just creating G-Cloud commands to create the cluster and all the cloud resources. So this is a pure G-Cloud version, but they all work basically the same. Whether using Terraform or G-Cloud or any other tool, the cloud resources are set up, and then once the cloud resources are set up, the Git operator is installed and everything else is kind of identical. So the reason I wanted to show you this one is because this one is fully booted, we've resolved the Helm file. So notice the Helm file now isn't just this limited minimal set of dependencies. It's got a list of fully qualified repositories. So they're all repositories that's being used by all the charts in your original Helm file. And then for every release, it's got the explicit version number in it, which namespace it's going to be deployed in, a unique name for each release if there wasn't one already. And for lots of charts, it adds value files, such as these and these and these. These values files are either a static values.yaml or they can be a Go template. And the Go templates are a Helm file feature that lets you generate values YAMLs files using Go templating. Now, if you don't know anything about Helm and Helm file, don't worry about any of this. It's all just implementation detail. But if you do know about Helm and Helm file, this bit might be interesting to you. So Helm file lets you use templating to make values files. And you might think, well, why do we need this? Well, it turns out that you sometimes want to pass in different data to Helm. So Helm typically takes values files on the command line when you're doing a Helm install, Helm upgrade, or a Helm template. Helm file lets you pass in values files or values template files. It's up to you. And what we do in Jenkins X3 is the first thing we do is if your repository doesn't contain a version stream, we copy a version stream into your repository. So here's a little version stream folder. This version stream starts from a shared shared Git repository. So I have a shared Git repository with all the version stream in. So everyone starts with a known set of versions that all work. And usually you don't need to touch this version stream folder at all. It just contains all the data you need in one Git repository. If you're tweaking things, it means you can upgrade versions locally in your version stream to try things out, but typically we don't expect you to modify this. We upgrade the version stream dynamically and automatically in Jenkins X3 for you. So this is implementation detail you don't need to know about, but just it's something you can kind of tweak. Here's information about the version streams. The version stream has charts. There's information about all the charts, and this is how the charts work. You have a folder for the chart prefix and then the chart name, and that file has a YAML file to define the version. The repositories are defined there. You can kind of read these docs at your leisure, but the values folder lets you define folders containing values YAML files that allow you to inject dynamic values from your configuration into Helm charts. Now let me show an example of why we do this. So if you look at the Tecton values YAML, the Tecton values YAML lets us pass in various different bits of metadata from the requirements file, such as what project name are you using, what cluster name are you using on GCP, on EKS, what cluster name are you using on EKS or GCP. So it allows us to take dynamic values from the configuration of your cluster and inject them into charts. And this works with any chart, right? So we can use any upstream chart and inject values from the configuration into charts in a single canonical way. But this basically means we can templatize values files for Helm charts in a single place, and we can share them across all environments and all users. So what this basically means is out of the box, you don't need to configure anything in Jenkins X, it all just works. But we have an extensible way that you could tweak the configuration. So in the Helm file, you could add your own, if I go back to the Helm file, in the Helm file, if you really want to set a specific value in a chart, you could just add a new values file here and point to any file in this Git repository that you want, right? You could use any file from the version stream, or you can just point to any file you like. Or using Helm file, you can specify explicit values directly in this YAML file if you wish. So everything's completely configurable. It's really, really simple. Well, as simple as can be, really. And one of the big design goals of Jenkins X3 is we want to have the smallest set of things to learn for you to be productive. So if you know anything about Helm and how Helm works with values files, you should be able to just pass in one of those values files into any of these Helm charts and it should just work. The nice thing about the way this all kind of works is you can git clone this Git repository and you can run Helm file template on your laptop and see what actually happens when you run Helm template or Helm file template. So it's really easy to modify the YAML locally, see what's actually going to happen, and then be confident of the changes you've made. Traditionally, we've often had quite a lot of magic in Jenkins X. We had the JX step Helm commands that used to do all kinds of weird and wonderful magic to try and help users use secrets and certs and all that kind of stuff. Now we have this very thin, simple layer that's really just Helm, vanilla Helm. There's no wrapping. So it's vanilla Helm or vanilla Helm template or vanilla Helm file. The other thing that's interesting is when boot runs, it runs as a job in the cluster. One of the things it does by default, which you can opt out of, but one of the things it does by default is it checks into Git all of the Kubernetes resources. And it's doing this in a way that's very similar to the Flux project, and there's a project from Google called Google Anthos config something, forgotten the name. Anyways, yes, that's it. No, not config connect, it's the other one. Config sync, I think. Or it's maybe Google Anthos config management now. I think they've renamed it. Anyways, to cut long story short, we're using the same naming conventions as the Google product. We have a single config root. This is where all the YAML goes. Anything that's cluster level scoped goes in the cluster folder. Anything that's namespace scoped goes in the namespaces folder. And what this means is you can then tweak how the kubectl apply happens. One of the common problems we have, and particularly with environments like OpenShift, is you might not have cluster roles. So you might not be able to apply any custom resources or cluster roles or whatever. So by separating all the resources out into folders, so let's look in the cluster folder. So I have a cluster folder, then here's all the definitions of the namespaces, for example. So there's the Nginx namespace definition. So that's the custom resource that defines the namespace so that we can install Nginx into a different namespace. Now, if the GitOps operator job doesn't have Karma to install these, you can just disable installing these in the job, and you can use another job to install these. So maybe you ask an operator to install these for you, or you have a separate job that operators own and control that runs the cluster stuff. And if I look in here, we have custom resources in another one. If we look in JX, and if you look in, say, Lighthouse, Lighthouse defines some custom resources. So these are the custom resources that Lighthouse defines right now. So anything that's cluster level goes in the cluster folder, which basically means you pretty much need cluster admin to apply those things because they're all global in the cluster. Then the stuff that goes in the namespace folders is, it starts off, the first folder is the namespace name. So if I look in the Nginx folder in the Nginx ingress, these are all the resources that get applied to deploy Nginx. Now, the really nice thing is you can forget all about Helm and Ket and Customize and Helm file and all that stuff as a user, you can just look at what will actually be deployed. So let me look at the deployment backend for Nginx. This is it. This is the vanilla complete deployment resource that will be applied by Jenkins X. So you can see exactly what's going on. Now, if you want, you could just modify this directly. However, we do have a pipeline which will regenerate these things. So we'd rather you modify the pipeline to make modifications, whether that's via customize, Helm templating, a command line tool of your choosing or whatever. But the great thing is, in a Git commit and a pull request, you can see exactly what's actually going to happen in Git. And at every point in time, we see exactly the resources that get applied to Kubernetes. So from an understanding perspective as developer, you can just look at a pull request and look at the actual resources in Kubernetes in Git. And you can just ignore all this pipeline stuff that uses, Helm and Helm file and kept and customize and whatever other tools you might wish to use. Those are kind of just intermediary tools to make the declarative output. So to say that a slightly different way, everything in Git is completely declarative in Jenkins X3. So you can just look at the Kubernetes resources in Git and that's it. You don't need to understand anything else per se. Another interesting thing, this is a BDD test and we've done a promotion to the staging repository. Now another change we've made is by default, all local namespaces. So by default in Jenkins X, we had dev, staging, and production. And by default, those environments are all inside the same cluster. So in Jenkins X3, all local namespaces are in the same Git repository. So we just have one Git repository for Nginx, Vault, Jenkins X, and anything else you install, right? Cert Manager, Flagger, Istio, literally anything you want to install via Jenkins X all goes in this one Git repository. And you can use any namespaces for anything, right? So in this case, we've put all the Vault infrastructure in a separate namespace. So here's where we're installing something called Kubernetes External Secrets. There's a Kubernetes External Secrets deployment, which is a really awesome thing by GoDaddy. Then there's the Vault. Here's the Vault instance, which defines a Vault role binding and custom resource and stuff. This is the Vault custom resource that defines a Vault in this namespace. So you can basically just walk around the Git repository and see everything that's being installed. The JX folder contains the Jenkins X installation, which has these bunch of charts in it. There's the Lighthouse stuff, there's Chat Museum, there's Nexus, there's a bunch of source repositories, and there's Tecton. So it's fairly straightforward, and you can zoom into any one of these and see what's going on. So it's quite easy to look and get and understand just by looking at the YAML what's kind of going on in your Kubernetes cluster. If I look at this folder, this is a promoted quick start as part of the BDD test where we've created a new quick start and we've asserted that this quick start deploys to staging. And we can see all the resources that got deployed to staging. So here's the deployment for the quick start. This is the namespace, it's going into JX staging. And we'll notice also there's an ingress created for it. So there's the ingress and there's the host name and everything. Notice that we're not using any of that expose controller magic or any of that other kind of stuff. We're just using vanilla ingresses, vanilla services, or if you're using Istio, the various Istio service resources, or if you're using Flagger, the Flagger resources. We're basically just using vanilla Kubernetes resources. So if you kind of squint and don't worry about how the job works and the makefile, you run your install process that installs this operator. The operator then just creates resources in this tree. And it's really, really simple. And you can see exactly what's going on. Any questions on that so far? It's a bit of a quick brain dump. Makes sense?
It does make sense.
Awesome. Phew.
We need to try it out. That's the
yes, absolutely. Oh, I should mention this other file here, JX values. This is one other file I haven't. So I'll just go through all these files. We've got the Jenkins X YAML, that's the pipeline. The requirements, we know about that. The make file we talked about, the README. There's also this JX values file, which is just a YAML file, which just has the JX requirements inside this JX requirements key. And the way the reason for this file is we pass this file by default into Helm charts, which you can opt out of, but it just means any Helm chart that needs to know what the domain name is or anything to do with certs, we can do jx requirements.ingress.domain inside the chart. to do things like defaulting the ingress values and whatnot. So lots of things like ingress or whether or not you're using Vault and all those kind of things. You might want to pass those values into any chart. So this JX values gives us a nice place to put common configuration that we can share in any chart. But yeah, Mauricio, I mean, I'm hoping we can all just kick the tires fairly soon on this. The BDD tests have been reasonably stable for a little while. The main thing we wanted to do is just polish the UX, so the UX is just as clean as we can get it before people start really hammering on it, to avoid us having to kind of keep changing the UX a lot and then changing the docs and everything gets a bit confusing.
Can I ask you a question? Like on the beginning, when you do the first installation, right?
Yeah.
And you share the docs. In the docs, you have like the button to create the repository, and then you have a configuration like script, right?
Yes. Yeah.
And then the question is like you need to have Terraform installed in your laptop. It's not like before that you installed all the requirements to install everything. Okay.
Oh.
Yes. Currently, yes. Okay. James, can you demo anything for Terraform Cloud right now, or is that maybe too early? Well, if you are using Terraform, there is a tool called Terraform Cloud that I'll let James talk about, which means you don't have to install anything locally. Yes. So.
Oh, I can do it. I can do it. Yeah.
No, let me stop. I've stopped. Yeah.
Okay. Okay. Yeah. Terraform Cloud. It was a very good question, Maurizio. One of the things I think,
it wasn't scripted, right? Like it wasn't.
It wasn't. One of the things I know personally I struggle slightly with around Terraform is probably some of the initial UX and just being able to, things like the state file and a couple of other things. Gareth Evans maybe a year and a half ago, I think he's dropped now, he did an example of using our Terraform repos, but using CodeShip. Since then, Terraform Cloud has come out and it basically looks very, very similar. So I don't know if anybody's familiar with this, but this is what we're working on at the moment as well, as an answer to kind of improving that initial UX, kind of limiting the scope and making it super, super easy for people to get up and running in a good way using our recommended approach. And so limited the areas where they could go wrong. Again, kind of having limited the script, having those lines of let's create the infrastructure, and then let's also then, as draw a line, let's have an installation, which is what James has also just been talking lots about there, having that synchronizing of state, using all those design principles that other projects have done. But this is Terraform Cloud. There's an organization that we've got at the moment. The idea is you can add in these are our modules that we have at the moment, the Terraform modules, so you can filter on Azure or Google ones, and you can actually build these up and actually build up a repo this way. That's one way of doing it, but again, we're just trying to figure out that ideal UX, as James was saying. Go back to workspaces. Here's one we have at the moment where we just created a workspace, and we imported that Git repository that James actually mentioned there. It's that same one. And then we apply it, and we give it a GCP service account key, and currently a pipeline username and token, but maybe we don't include that and we just use the JX operator that James was saying, but we're just toying with what is the right boundaries of lines. But this is exactly this. You don't need Terraform installed. The state is stored, encrypted in the cloud, and it gives you a way to kind of get up and running very, very quickly. I don't know if that helps. Some of that.
But the main reason we really like Terraform Cloud is, firstly, you don't have to install Terraform locally. But then secondly, if you're using Terraform for real with more than one person, you're going to have to set up a Terraform state resource. So you need to create a cloud bucket or something. So you have that kind of catch-22. How do you create the cloud resources to use Terraform to create the cloud resources? So you end up having to do things like run gcloud commands on the command line or Amazon commands or whatever to make buckets, and then configure your Terraform to point to the buckets and all that kind of stuff. So you've got that kind of bootstrap problem. The great thing about Terraform Cloud is, well, it's free for small teams, which is awesome. And it does the state for you. So you basically just point at a Git repository, and it basically prompts you for the missing data that you need to populate. And then it basically works almost like a CI server. So it's a really simple way of bootstrapping cloud resources with Terraform. Now, we're not saying Terraform Cloud is mandatory or anything like that. It's more, we're trying to make the simplest possible way of bootstrapping Kubernetes clusters and cloud resources that you can then install Jenkins X on. It doesn't really matter how you want to use Terraform, or even if you want to opt out of Terraform, that's kind of fine too. We'd rather use Terraform if we could. But where it gets even more complicated is if you want to do multi-cluster, multi-cluster means multiple Terraforms, multiple Git repositories, setting up multiple clusters. As soon as you have 3 or 4 or 5 or 6 or 10 clusters, life becomes really quite complicated. So doing everything the hard way, installing Terraform by hand, setting up a bucket per Git repository with Terraform, you can totally do that, but that kind of gets stale pretty quickly. So the thing we really like about Terraform Cloud is it's cloud agnostic. You can use it for on-premise, you can use it for any cloud, and it just speeds you up with your Terraform stuff. So it becomes fairly simple, particularly if we already have the Git repositories created that has all the Terraform magic inside. Now, it's not quite totally working yet, but it's almost totally working, where from a quick start Git repository, you can import it into Terraform Cloud and it basically just works, assuming you've set up your GCP or Amazon or Azure identities and whatnot.
And added to that as well, it's quite a nice UX, but James kind of started saying, alluding to it, but around having the local environments in that Git repository. Of course, all of this makes it super easy then by default for Jenkins X to be set up for multi-cluster by default. So, but again, one of the hard things around that is how do you manage all the multiple clusters? And again, Terraform Cloud has a nice UX to be able to do this as well. So you could have a development and staging and production cluster here, which is all corresponding and managed by Terraform as well.
Are we still relying on vaults being exposed via ingress? Or
Great question. Great question. By default in Jenkins X3, there is no exposing a vault at all, ever. So by default, any access of vault is done inside the cluster using Kubernetes services. It's easy to use environment variables to point anywhere you like, so you can specify the vault address to be anything you want it to be if you've got some kind of weird or wonderful setup. But by default, there's no access of vault at all on a laptop. It only accesses vault when it's running the boot pipeline inside the cluster. And that by default uses local services. So yeah, that's a great question. We've had all sorts of fun and games with Jenkins X 2.x where we had a really complicated setup process using Vault. We needed Vault to be exposed over ingress, and then all sorts of kind of complexities jumped in. We've gone for something really, really simple now. Another thing that's really, really simple, let me just share the screen again. Oh, actually, you're just showing external secrets. Let's use your screen, James. We've defaulted to use something called Kubernetes external secrets. Now, the main reason we've done that is simplifying what Jenkins X has to do, but also making things more flexible. So Kubernetes external secrets is an awesome open source project by GoDaddy, which basically abstracts away how to load secrets from cloud infrastructure. So there's lots of solutions out there for managing secrets. You can have internal vaults, external vaults, Vault as a service. Then all the cloud providers have their own secrets as a service offerings as well as Vault as a service. So Amazon, Azure, and Google all have their own secret managers, which are not Vault. They're typically much simpler to use if you're using Google or Amazon or Azure. They're much simpler to use because you just create a secret and it's just there. You don't have any vaults to manage or anything like that. And you could typically use the standard IAM role-based authentication in your cloud provider to access the secret securely. And each secret can have its own IAM rules and everything. So Kubernetes external secrets lets you work with Google, Amazon, or Microsoft, or Alibaba's secret managers, or Vault, wherever the Vault may be, internal Vault, external Vault, shared Vault, on-premise Vault that's not even in Kubernetes, like just any old Vault. Now, the other thing that's awesome about Kubernetes external secrets is it means you don't have to check into Git secrets. One of the things we've always struggled with is worrying about checking secrets into Git, which is the way secrets are used in Helm in particular, you pass secrets in on the command line to Helm install or Helm upgrade or Helm template. And it was so easy to accidentally check in a secrets.yaml file that has in all of your secrets. One of the lovely things about using Kubernetes external secrets is in Jenkins X3, we never even touch a secret in Jenkins X3. We create external secrets. And external secrets is a custom resource that James was just showing on his screen a moment ago. And an external secret is kind of like a pointer to the secret or a reference to the secret. For Java folks, it's a little bit like talking about a JNDI reference to the thing you want rather than the thing. So whenever you have a custom resource called external secret, there's a microservice that will take that external secret definition and populate the secret with the data from the external secret. So as the example on the screen shows, this is an external secret that says we're going to use Vault, and here's where in Vault the data is for the secret. So basically you can have some secrets in Vault, some secrets in Google Secret Manager, some secrets in Amazon Secret Manager, some in Azure Secret Manager, like whatever. Use whatever secret managers you wish and whatever vaults you wish. And each external secret gets resolved to a secret when that secret is populated. Now, the other nice thing is at any point in time, anybody can populate any of these secrets in a completely generic way. People have had lots of trouble over the years with Jenkins X with, we used to use things like magic vault URLs, and sometimes those vault URLs worked and sometimes they didn't, and it was kind of complicated, it was kind of weird. Now you just create an external secret in any namespace, in any cluster, and whenever the secret is populated in the underlying store, it gets turned into a secret. So it means you can, at any point in time, modify any secret anywhere for any application via Vault directly, or via a command line tool, or via the G-Cloud command on Google, or the Amazon command or Azure commands and those clouds. As soon as a secret is actually modified in the underlying storage, Kubernetes external secret modifies the secrets, which then triggers the running upgrades of all the services. So it makes it much simpler to manage secrets. The thing I particularly like is we can manage secrets for every application the same way. So your production applications, if you wish, can use external secrets. Any tool you use, you know, Nexus or whatever, can use external secrets. Any charts that, or YAML you install in your cluster can use external secrets if you wish. It's completely up to you. And then everything works the same way. Let me grab the screen a sec, James. I'll just show you. One second, shared screen. We've created a little command line tool. Okay, well, 1 second there, share the if I go back to the JX CLI, if I go back to this repository, which has all the main things inside it, one of the new subcommands is JX secret, which is a little microservice that helps you use Kubernetes external secrets. It's a really simple command line tool. Let me just show you it in action 1 second. Oh, my laptop's going a bit strange. See if this works. So I've got a cluster I booted up, and this bit bigger. I've got a cluster that's partially installed, and I've got a bug in the secret population right now. But if I type secret verify, it's going to query all of the Kubernetes external secrets and list which secrets are valid and which secrets are invalid. So it means we can have mandatory secrets, optional secrets, we can have different schemas to define each secret. And we'll see that I've populated Nexus and I've populated Lighthouse's HMAC token, but I haven't populated the Lighthouse OAuth token yet. And how all this works is if I do kubectl get external secrets, we'll see these are all the external secrets resources in the JX namespace, and we'll see that one's successful. So if I look at that one, kubectl get external secrets, or YAML, plug into more. This is the external secret, so it defines this is using Vault, this is where in Vault it should be, and the status is success, which basically means it's made that secret. So there is a secret now called Nexus, which has a property called password, and it's read from that location in Vault. So that one's works. If I look at all the secrets again and find one that's not valid, so that one, so if I look at kubectl get external secrets. So this secret isn't valid, So we know that path in Vault is not populated correctly, right? So we have lots of commands, JX secret help. We've got lots of simple commands that let you populate defaults, secrets from a schema. We can import using a YAML file, we can export using a YAML file. So once you set up some secrets in one cluster, you can export them as a blob of YAML and import them somewhere else if you want to quickly populate your secrets. There's a command line tool to edit the secrets. Secrets. Edit.
Interestingly enough, yeah, all I was going to say, because it's also, a lot of these things we're kind of, we think it's there, but it's then, because we've also, there's things around with GSM as well, which is kind of half there for Google Secrets Manager and various things. So it's just trying to get, I think to Richard's point, was just verify we're hitting the right UX for certain things rather than building on something that we're not quite sure of. And we've kind of changed this a little bit, even just within the last week. But it's pretty much almost there. It's just how making sure we got the lines are drawn in the right place, so that when we're actually contributing on top of it, that we're actually we're building up the right areas, and we're not working on already kind of areas where probably we need rework, for example. So it's not that it's not. I mean, it's there. People could get involved and kind of start noodling the code and everything. We're probably, hopefully, not very far away to get that initial. Super easy, people kicking the tires and giving that feedback, and then diving into issues and things as well, and giving feedback.
So just going back to Terry's question, actually. So if you want to edit secrets locally on your laptop, you need to run JX secret Vault port forward so that you can actually talk to Vault, which is port forwarding the internal service Vault to your laptop. So then the secrets edit command lets you edit the secrets dynamically. By just typing in the command line, it will update Vault. So I could type in a secret there, and it's going to write to Vault under the covers. So there we go. We just populated the secret in Vault on my laptop by port forwarding to Vault without exposing it as an ingress.
Which in turn then syncs back into
up and ready. Yeah, which will then populate the underlying secret automatically. Now,
so
the interesting thing about go on, thank you.
Sorry, it's very good. So imagine secret rotation, which is something that's always been the trouble within Jenkins X. You change a pipeline token, for example, you just got one place, you change it in that, and then it gets replicated across all the Kubernetes secrets, and your pods, then anything that's using the hash that James showed earlier actually gets updated as well. So
you see, I just populated that one. So that's now green. It wasn't green before. So I've manually populated that secret. So the nice thing is we can basically populate any secret using any tool. Now you could opt out of this JX secret edit stuff, and you could just edit them direct using Vault, or the Vault web UI, or using the G Cloud command if using Google Secrets, or the AWS command, or a web UI in your cloud provider. Another thing that's interesting is because we're exposing this on localhost 8200, we can look at the Vault UI in the web browser. Oh, HTTPS, I think that works. See if this works. So we can just use the Vault web UI directly. Although I can't remember how to log in. But if you can remember how to log in, you can use the Vault UI to populate your secrets directly as well, if you do the port forward command. So if you run this JX secret port forward command, you can just use the Vault web UI and populate your secrets. So we don't really care how you populate your secrets, right? You could use Vault, you could use GSM, Google Secret Manager, Amazon Secret Manager, Azure Secret Manager. It could be internal Vault, external Vault. We really don't care how Vault is provisioned. You can provision it yourself. You can provision it with Jenkins X. We don't really care. But once the secrets are in the underlying store, Kubernetes external secrets will do the heavy lifting for you, which is awesome. And you can manage all your secrets this way. So all the secrets for every application you use, you can do this. So whether you're using Cert Manager or external DNS or Nginx or whatever, you can do everything this way, which is really nice. We hope to have an Octant UI to manage secrets as well fairly soon. Sorry, Terry. So question.
There's an excellent step forwards in maturity. I think that's going to be really, really good for the whole community.
Definitely.
So all the things that you just explained, actually throughout the whole talk, the whole office hours, are super helpful, especially when you're not trying to rely on magic. Having the explanations of everything.
Yeah. Yeah.
So what can we do to get these things captured better in documentation?
We've started to try describe, well, we've got some documentation in the pull request that's coming soon. It's still early days, but we're trying to do guides on how everything works.
I mean, I'd love to take, like, I could transcribe what you've said here and apply it to paper. You know what I mean? I mean,
that would be awesome.
I'd like to help in any way I can, because I've been frustrated so much that, I want to try and get rid of that frustration across the board. Right?
Awesome.
I think
so. I've got a pull request almost ready to preview. Well, the pull request is there right now. The pipeline's failing because there's some bad links. If you want to have a look at the docs, they're here. Let me post it in chat.
The other question I have is with all of these Git repositories for each different iteration of configuration, how do you keep all those maintained? Because it seems like you guys are spread a little bit thin as it is, Great
question. So one of the things we've always struggled with, well, particularly with Jenkins X2, is we had this Jenkins X boot config repo that whenever you booted, we'd fork that repo. And then we'd be changing that repo all the time. And then if you then change your local repo, there was all this kind of rebasing, remerging stuff that would happen that was really complicated and confusing. One of the big changes in Jenkins X3 is now the Git repository is basically yours and you can do whatever you want with it, right? So the Helm file is basically your Helm file. You can edit this and do whatever you want with it. However, we want to share some things across all the Git repositories. I'll just show you how the sharing works. Let me close these other tabs so it's not confusing. Actually, let me open the previous thing.
Just while we do that, we're almost a minute rest of the time, but if people drop off, but we may as well try and keep going a little bit more, because this is a good one to cover off, a good question to have if people are able to stick around, I think. But catch up on the recording. If not, we'll post that and let people know. Yeah,
and hopefully upstream we can document everything we've talked about fairly soon and do nice demos and lots of really good docs that can help people understand all this. But let me just show you how the version stream works. So here's the version stream, but the same is true. Actually, let me show you. Here's how the secret mappings work. So this is how we're mapping all the secrets into Vault. So because we're using Vault, these are all the paths where the secrets are going to use for Vault. So if you want to use different paths for Vault, you just edit this file and your external secrets will use different Vault secret mappings. Right? We have lots of little bits of config in here. Now, initially, this config comes from a shared place, and you can upgrade each of these folders over time as the upstream repo changes. And there's this tool from Google that does this called kept. Let me show you. There it is. There's a tool called kept. It's spelled KPT, but pronounced kept. And it's a little command line tool that lets you grab bits of Git repositories and share them across repositories and then upgrade them. But it does let you make local modifications if you wish, and then merge changes upstream over time. So typically, you probably will never need to change your secret mappings at all, ever, typically. But let's say you decided you didn't like this path and you wanted to put the HMAC token somewhere else for Lighthouse. Crack on, modify the file, just modify the file in Git, you're good to go. But then at a later date, when Jenkins X does an upgrade and generates a pull request, it will use a tool called kept to manage this file. And kept creates a kept file, which keeps track of the Git repository and the folder that created this directory. So if I look in here, this is our global template. Oh, sorry, not there. Copy and paste file. If I look at this Git repository here, this is our shared templates for all of the different quick starts. So if I look inside JX, inside GitOps, and inside Vault, this is the shared secret mapping file that is used in all the quick starts. So whenever we modify this file, we replicate this file into all of the quick starts, and you can use kept to upgrade your version of those files at any point in time in the future. So whether we're talking about version stream stuff or configs for secret mappings or configs for the GitOps, for the Git Operator, so if I look at the Git Operator, going here, and the Git Operator. Again, this Git Operator has a kept file because this is shared YAML that comes from a template, which you can modify at any point in time if you wish, and you can upgrade to future versions if you wish using kept.
This is a lot of stuff to document, dude.
we have kind of started to document lots of these bits. The bit we're missing is the navigation between the bits. So there's a JX GitOps project, which is a little command line tool stuff, and it talks about secret mapping and secret mapping references and the Git repository layout. So this describes how the Git repository looks and what the folders are called and what goes in each folder and how secrets work and blah, 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 all that kind of stuff. So we've started to document all the pieces. And if I look at the command line reference for JX GitOps, there's a command in here. So let me mention some of these commands. So this is completely low-level implementation detail, but if you ever want to add an annotation to a resource, there's an annotate command that you can just run this annotate command. And it's really, really simple. This annotate command, you just tell it which directory to annotate and which kind of resources to annotate. So you could say, I just want to annotate the, in this directory, I want to annotate all resources with foo equals var. And you just run that command and it will do some annotations for you. So we can add labels, we can add annotations, we can change images, we can add hashes and all sorts of stuff. So we've got a gazillion useful commands here. We can set the namespace on resources, we can set the label, but this is a command I was going to show you in kept and kept update. The command JX GitOps kept update will query the directory you pointed at and look for all kept files. And for any kept file it finds, it will run the kept upgrade command, which will try and upgrade to the latest version of that Git repository. So in other words, we've got a way of sharing GitOps source code, whether that's configuration for secrets, configuration for the Git operator, whether it's the version stream, whatever it is, it doesn't really matter. We can use kept to share those across repositories and have a consistent way to upgrade them. We've always had all these custom bits of code in Jenkins X for doing upgrades. We've now got a generic solution for doing upgrades, which is awesome. I mean, I'm not saying it's fully baked and there aren't going to be issues. I've definitely found sometimes when doing a kept upgrade, it's kind of failed. One of the nice things we've kept is you can always just replace and do a kept package again, which let me show you this.
Can I just jump in, just very quickly, just to David's point. One of the things, I guess, again, through feedback we had with Jenkins X is the documentation isn't necessarily always up to date. This is a little bit here, a little bit there. So what we want to do as part of that is ensure that we have good quality gates with how we roll out Jenkins X3. We saw James was talking about Jenkins X Alpha, so we want to get to an alpha first. And that is, we want to define what we want to be doing, which includes documentation. We want to include what we need to be achieving to get to the next part. Whilst some of the experiments we've been doing, we could have documented, but we've already thrown them away. So it's about just we wanted to share this as soon as possible, what we've been doing. We know it's kind of, people want to get their hands on it. So it's just a case of getting something that kind of works. It's there, it's a lot of the principles, it's not going to be fully polished, but then documenting the way and then get people involved, and then we can start working together as well about giving the feedback, but also ensuring that there is documentation on the areas that we identify that people need to be getting involved in. And so that we get those quality gates to get to a beta and then to a GA.
It's almost like, if I can make a suggestion, every PR should have a documentation requirement to get it approved.
I think
yes, it should.
Again, it's one of those things about how much, if something isn't necessarily working, then you need to know what it is until it gets there. But you are right. When we get to a point, we need to have, whether that's an alpha or beta or some kind of feature, for that to get to a mature level, it needs to have supporting documentation with that. And right now, we haven't actually been putting, James has just got the PR for the website, so that'll be going up and we'll be able to start adding on there. One of the other areas we did think about before, but we never actually implemented, was a review comment, so a text on comment, so that we can actually say, okay, this requires this needs, like the needs okay to test, almost this needs docs, and so that we can kind of sign that off and automatically link it, so it cannot be approved until we have corresponding docs. But you're right, it's just getting to that point, I think.
Just one thing on the docs for a second. One slight change we've been making with the new microservice approach of Jenkins X3 is, so this is the top level CLI project, which links to everything else. If I click on one of these, let's do the secret one because it's a smaller one. the docs for the secrets are in the Git repository for the secret code. So it doesn't quite work yet, but what we want is whenever there's a pull request on the secrets repository, it regenerates the secrets documentation. So the docs for secrets are always in sync with the code, right? So rather than having this big uber monolithic website, we're trying to put a lot of the like lower level kind of implementation detail docs in this where the source code lives, which just is kind of scales a bit better.
Go Docs has had some really great stuff as well, and also has a lot around deprecated features as well. So that being able to auto-generate this and build up more code quality, including docs as well, supporting documentation of Go Docs within the code. And as James kind of explained, then using that to update the website means that we're kind of a lot more in sync, and we'd have less risk of things getting out of date. And when we're deprecating things, it's clear and understood.
Yeah, because one of the things with JX2 seems to me that it's moved so quickly and changed so radically in a short period of time that, you know, there's tons of stuff out there that just is, you know, out of date.
Yeah. Yeah. And
yeah.
Again, one of the things, sorry, go on then, Jason.
I was just going to say another problem we've had is we want to be able to go fast and make new things. But we want to be able to label those things as like experimental or alpha or beta, whatever. So we want some things that are stable and some are alpha. And we want a way of being able to everyone understand what state of quality each thing is. And having a monolithic like global config model hasn't worked that well. So we're starting to move to having lots of separate small config files for different things. And here's a quick example. JX promote lets you configure exactly how promotion works inside a Git repository by using a promote YAML, just like the secrets mapping we just saw before. And in here, we've documented the config for this like microservice, and also have we have docs. Yeah, I think we've got the generated reference docs as well inside the Git repository. So you can look at all of the different values in the promote spec. So if I want to promote via a Helm file, what are all the values I can specify and so on and so forth. So rather than having a central point that gets quite complicated, we're trying to denormalize or modularize the help and the documentation so that it goes closer to where the code lives. So some modules and microservices can go really quickly, some can go much more slowly. And then we've got the option of copying the configuration and the docs into the global website whenever we think it's good to do. So we can iterate quick and then share docs.
Can I ask one more question? I'm sorry, I don't mean to manipulate you. What's the plan for the timeline for the fate of JX2 versus the implementation of JX3? Is there any idea of that yet?
That's a great question. So we're trying to get Jenkins X3 out as soon as possible, but we're trying to build everything in a way that's not going to make a massive maintenance nightmare. So we're reusing a lot of the code from Jenkins X2 and Jenkins X3 where it makes sense to do so. So things like JX Preview and JX Promote tends to reuse a lot of the same code from JX2. It just configures it to not use Helm 2 anymore. Some of the stuff is clean, like if I look at JX Secrets is clean and is totally decoupled from Jenkins X, the JX repository. If you look at the Go module, JX Secret has virtually no dependency on Jenkins X2 at all. It uses some helper code, the kube client, and some config stuff, but that's it. So there's no dependency on Jenkins X-JX anymore. And increasingly, the new microservices, we're trying to move away from depending on this big JX repository to shrink the Go modules and the Go dependencies. So we're wanting images from JX2 to work possible with JX3 and vice versa. So if you have a JX step that does something like promote or something, we want to try and make those backwards compatible where possible. So we're keeping the same, mostly the same CRDs, like environments, pipeline activities, and so forth. Those are all the same. So the CRDs are pretty much the same. The binaries are slightly different, but they look the same. And we share code where possible.
Yeah, the other part of it is as well, we want to ensure that, because we're quite very aware that in the early days, Jenkins X changed quite a lot and people were receiving lots of changes and it was quite hard to keep up with these changes. So we want to keep things stable with Jenkins X2 as it is. That is their stable platform that people can be using, they running their production workloads using. But we then, as we get JX3, we focus as much as we can on JX3, we get that to a good, stable place. We achieve those quality gates that we were talking about before to get it to GA, whether that's automated testing on different cloud providers, different Git providers. We've ensured we've got documentation, migration, and understanding so that people can actually move over to that. We don't want to jeopardize the stability of what people have currently using, but the absolute focus from now is around development on JX3, and hopefully, the sooner we can get this be in people's hands. Let's aim for this week. Let's try. Let's do whatever we can, and then people can start feeding back and we can start sharing out the works. At the moment, it's basically not been too many folks. But Cara, you were going to jump in.
No, I was going to actually ask all of you, but Dave specifically, because you've sort of raised this point a number of times. Would you be interested in being involved in discussions on how we determine what makes alpha, beta, GA, and what we'll be looking for in those quality gates from an end user perspective?
Yeah, I'm at the point where I'm in for a penny, in for a pound. So yes, absolutely.
Great, glad to hear it.
Awesome.
Excellent. Good. So we'll be raising issues. Where do you think we should put that? The JX repo or the docs? What do you think, James? Let's
keep it out of I think maybe just for now, the JX repo is probably a little bit.
Okay.
Let's double check on that one, where the right place for that should be. I think maybe let's make a decision quite now, but hopefully tomorrow maybe we'll just get a good place for it.
Yeah.
Maybe so there's the JX CLI repo, maybe potentially
Okay.
Yeah. And there's a whole bunch of stuff we've never done a great job of before, because we've been trying to go fast and get everything to work. But I think from a docs front, helping people understand what's going on and making it as easy as possible to explain what Jenkins X is doing without necessarily having to know all of Terraform, all of Helm file, all of Helm, all of Vault, all of external secrets. So having a way that you can kind of get what's going on from a high level without knowing all the details, but then if you need to know one of the details, a way of diving into, there's a step using Helm file. Here's where Helm file is if you want to know. So having a way of helping people use Jenkins X without needing to know too much about the internals, but having a way to gradually peel back the curtain would be awesome. I think another thing we've struggled with in the past is because Jenkins X was often so big and complicated, it was really hard to know how to even start working on it. Whereas now we've got these small little microservices. If you just want to work on, for example, preview environments, there's a single JX preview repository that just does previews. So it's much easier for you to look at all the code that does previews in one little repo. And ideally, most of these new repositories have lots of test coverage. It's not quite true of all of them. I'd like reporting to highlight the bad ones, but most of them have really good tests now. So you can dive into any bit that interests you, whether it's secrets, administration, previews, whatever, pipelines, creating new projects, and just work on that smaller code base in isolation. And because it's a small microservice, it's easier for us to go quicker and test it independently and so forth. So hopefully we can make it easy to contribute to Jenkins X. And then finally, something I've wanted for a while is make it easy to modify Jenkins X to suit their actual infrastructure. Go on, James.
Oh, sorry. I think maybe there was a timing thing. Yeah, go on. Well, Kai's just put a link in there, and again, it's some of the things as well. It's those helping, making a clear message of where Jenkins X is helping. We're not trying to boil the ocean of everything. We want to have these clear separations of the infrastructure. This is how people can extend Jenkins X, so people can contribute and maintain their own parts that people can reuse as part of the project. But having a clear mission and understanding of scope of what Jenkins X is, of that core, is absolutely a good one. And I think that should be a part of it as well. I think that's a great link there.
Yeah, well played. That's good.
Can I ask a question to the Jameses? It seems that Jenkins X3 is vastly more flexible than Jenkins X2. And one of the ways in which Jenkins X2 was described as was being very opinionated. Now, would you say that Jenkins X3 is very much working to meet the users where they are and to help them with what they want to use. But where do you think Jenkins X3 is it still keeping its opinionated nature, and in what spaces?
I guess it's still opinionated, but it's
just not in the implementation potential.
Yeah, it's got areas of flexibility baked in. So, for example, it's got a strong opinion of GitOps. It's got a strong opinion of checking in Kubernetes resources apart from secrets into Git, so you can understand what's going on. So it's still very opinionated, but it's more. We've said, hey, you just write a makefile however the hell you want, using whatever tools you want, but we'd like the output to look like this. So it's kind of in between being opinionated and flexible, and being very flexible. And we're trying to define the, if you like, the contracts between those levels of flexibility. Like, if you look at Helm versus Helm file versus kept versus customize, they're all completely different. I mean, Helm and Helm file are quite similar, but the other two are very, very different. From a Jenkins X perspective, we now don't really care how they work, but we want them all to output YAML in a canonical layout. And we even have tools that if your tool generates a terrible layout, like Customize does, we can reformat the layout to make it consistent. So I guess we're aiming for points of consistency. So we're still opinionated.
Yeah. Like the folder structure was there. The folder structure is opinionated, where you have the clusters and the namespace resources, which is, that's where it's opinionated, and that's good, but that's easy to extend. People can then add in, whether that's Nginx or a different ingress controller, Glue or Istio or various other things. We want to be, there is that, you have that opinionated approach of how people use it, but then people can extend it. Also extending other points. Terry did like an extension of the pipeline before, and it wasn't particularly well documented, and it was hard. We want to make sure things are more easily extensible as well, and more documented. Having those clear lines of where people and how people can extend, building up marketplaces, building up areas people can actually contribute and maintain their own, like the Jenkins plugin model.
I mean, out of the box, we have customized support, but you have to edit the source code a bit to enable it, because we don't really need to use customized by default. But it could be that people have different layouts they like to do their customized stuff. So maybe somebody might want a pure customize where there's no Helm file. So somebody could go off and create a Git repository that just uses pure customize. Crack on, it's all good. However you want to do that stuff, it's fine by us. But we'd like to try and have consistency in the outputs of these tools. So whether using customize or kubectl directly or kept or whatever, in any permutation, that's great. So long as the output looks the same, or uses the same conventions, then we're good.
Another thing as well, around the different cloud providers, it's from a Jenkins X project point of view, it's going to be very hard to maintain automated testing every single change that we do on every single different cloud provider in the ecosystem. By having these clear lines, we want to be able to we say what it is that a cluster needs to look like for a Jenkins X installation to be successful on, so that we can have Terraform scripts or config connect or any other kind of repos get added to those quick start GitHub organization. We can have the badge on it to say how well it's been tested or whether it meets certain capabilities. But it just people can evolve that up and then maintain, like the Azure folks were wanting to maintain and run automated testing themselves, which is great, but as long as we meet certain points, then we can say, yes, that is ready for a Jenkins X installation to be able to carry on with.
One thing we've always wanted that we've never got to yet, which I think is fairly close now on Jenkins X3, is making it easy for anybody to have their own version of a Git repository, right? Where you tweak some Terraform stuff, or maybe you don't use Terraform and use something else, whatever. And you might use a different permutation of charts and a different permutation of configs and different permutation of tools. It doesn't really matter what you do that's different. You've got your version of things, which is using stuff in Jenkins X, but it's slightly different. What we've always wanted is for you to run our BDD test suite on your own infrastructure and then report back if things work, and have a distributed way of reporting back test results, which I think we're close to having something like that, which would be really, really awesome. So that anybody could then put forward their own templates. And if we see proof that it's passing all the BDD tests, we'll tag it as being approved.
That's actually the good one that we can't very, very quickly, but it's taking less around kind of the upfront or wizard approach during the installation and verifying things, actually leaning more towards things around health, Cuba Healthy, for example, and having actual nice monitoring and health of a Jenkins X installation whilst it's running, and continually verifying things as well, helping identify where there might be problems with tokens or secrets or just any deployment, but really building that up so that people are using more of the dashboards of Optum more so, rather than relying on a one-time installation to check everything's healthy, because over time something might become less healthy. So we're kind of moving more that direction around more monitoring and alerting around that side of things as well. That was a lot to take on, I guess. That was an hour and 23 minutes. I guess that's to the folks that have left, and people if anybody's actually gone this far on YouTube and watching it afterwards. I probably should say watch it on 2x speed at the start of the video, shouldn't we? I know there's probably going to be lots of questions, and there is a lot of work that we're trying to do to get it out so that people are using it. It's not really wanting to hide things back. It's actually making sure it's get out there in a good consumable way. So hopefully it's going to all provoke lots more questions. There is going to be lots more demos. There's lots more focused areas. We can have different SIGs that we want to be pushing towards once we get things into a good place. So we can have more focused development areas. We can have a lot there, encouraging feedback and finding out issues where people can dive in and help. So it's very, very close. It's very, very exciting times, but yeah, we might want to save the net rest for the next office hours, but maybe we can, if people go along, then reach out on Slack and, I guess, and start talking about it and start asking questions.
And as soon as this pull request that I mentioned in the chat, as soon as that creates a preview, I'll post it to the dev channel, and then we can all start reading the docs, seeing if they make sense, discussing the docs, hacking the docs. Because it'd be awesome if we get to a stage where the docs kind of make sense, and we could maybe get some volunteers to try it out and see if it works for them. And if it seems to work, then we'll publish it, and then people could try it. And we'll just spend a couple of weeks seeing, well, let's see if we get it to work this week. But see how long it takes. We're not in a massive rush to get it out there, but at the same time, the more feedback we get, the sooner, the better it will be. So I hope we can get a real release out there. I mean, strictly speaking, all the bits are out there on the internet. It's just we've never really described how to use it yet. So as soon as we get these docs into a state that it's, it kind of works if you follow the docs, I think we can let folks start kicking the tires.
Real quick, are there any pipeline syntactical changes between 2 and 3?
Not yet, no. It's all the same.
Okay.
It's all the same.
Going forward, there is things we want to be doing around standardizing more so on Tekton and Tekton catalogs. There is nice, if we do go down that route, there is easy migration paths with that anyway. It's all syntactically the same anyway. But that's something that we do want to get to sooner. This is just about installation and ensuring we've got that clear grounding for Jenkins X3, and then looking at, to be honest, we want to be going for improving developer experience. That's where the value add for Jenkins X is. We want to make the core part solid and clear and sounding good UX, so that we can get onto things around pipelines and lots more interesting things as well.
I mean, to say that a slightly different way, there won't be any new syntax for pipelines. Yeah. But we'd like to encompass Jenkins X pipelines and Tekton catalogs. So it's either Tekton YAML or it's Jenkins X YAML, or both, or any permutation of them. So we'd like developers to be able to consume any YAML of any flavor, whether it's a Jenkins X pipeline YAMLs or Tekton catalog stuff.
Alrighty.
That was a long one. Sorry about that, everybody. We'll try to be much more concise next time. And maybe just do a live demo of how it works and less rambling. And
hopefully it paints some of the context and everything that's where it's focused on, and it is happening, and it's close. Should we call it there?
Yeah, fantastic office hours. Thank you for the demo.
Yeah, thanks very much.
Thanks a lot.
Okie doke. Take care, everyone. See you online, and see you for the next office hours in 2 weeks' time. Take care.
Thanks a lot. Bye.
Bye.
Bye.